Hello, so today we are talking about probability and simulations. So we're going to focus on simulations today because they're going to lead us into understanding probabilities and how we use probability models to model chance behavior. So this goes along with section 5.1 in your textbook. Feel free to look there to follow along. You'll also see page references today that can help guide you to the correct page in your textbook. So we're going to review key point number 1 from last class. It says the probability of any outcome of a random phenomenon, so we're talking about random events or chance behavior, is the proportion of times the outcome would occur in a very long series of repetitions. So probability, proportion, they're the same thing, and it's the proportion of times we would see that outcome. That's its probability in the long run. So law of large numbers tells us the more times we do things, the more accurate this proportion is going to be. So how do we model probabilities? How do we use simulations to model this chance behavior? Well, there's steps of a simulation, and like I said, here's a textbook reference. This is page 296 in your textbook. Go there. Use your textbook. Your textbook is a very valuable resource, so make sure you look at page 296. So the 4 steps we have are to state, plan, do, conclude. Feel free to pause this video so you can record all of these steps. You need all of these steps and their information for full credit. So first is to state. We want to ask a question of interest about the chance process. Essentially, you're just restating the problem. So you have to state the problem. AP readers are looking for this. I'm looking for this. Your assessments will be looking. That you state the problem so I know the AP reader knows what point you're trying to make during your simulation. So restate the problem. Step 2 is to plan. So in the plan, we need to describe how we're going to use a chance method. So chance methods are going to be like rolling a die or using cards or using your random number generator or random digit table. And we need to describe that process in really clear terms. Some points to help you are what will you record at the end of each repetition? So what are you looking for? What's the result that you want? And then what does one trial look like? What does it look like to do a trial of this simulation? And we're going to see some examples of these in the video and in class. Step 3 is to do. So we actually carry out the simulation. Perform many repetitions. The problem will give you a set number, or you can choose that number. And we'll see more examples of this too. Step 4 is to conclude. So we use the results of our simulation to answer the question of interest. So we're answering the question that we asked up here. So step 4 loops us back to step 1, making this a cycle, not just 4 random bullet points. This is one simulation, so it's going to be cohesive when we answer the question that we asked up here. Also, make sure you use context. You'll see examples of this, but this is where points can easily be deducted on the AP test. If you don't answer in context, that's going to reduce your score, and those are easy points to get. So let's take a look at an example. It says professional tennis players bring multiple rackets to each match. They know that high string tension, the force they hit the ball with, and occasional racket abuse are all reasons why rackets and strings break during matches. Suppose a tennis player has a 15% chance of breaking a racket in any given match. How many matches, on average, can he expect to play until he breaks a racket and needs to use a backup? Design and carry out a simulation to answer this question. So they just gave us a prompt, and we're given a percent, what we're looking for, how many matches, and then a prompt to design and carry out a simulation. So I asked some questions down here, and we're going to go through these. Where to begin? A lot of times with problems like these, you're given a lot of information, and it's kind of like, okay, what do I do next? How do I design and carry out? Well, the first step is to say, what percents and proportions am I given? Well, if I think about, I'm given 15%, that's the only percent proportion, anything that I'm given in the problem. So 15% means that he breaks a racket. He breaks a racket 15% of the time. Step 2 says, what would my labels be? We'll talk more about labels and how we develop them as we go through more problems today and in class. But if I'm modeling a percent, my labels are going to be 0, 0 to 99. It represents all possible outcomes. If I think about percentages, I go up to 100%. So I start at 0% to 100%. So I need 100 labels, and 0, 0 to 99 are 100 labels where I count 2 digits at a time, and each of my 2-digit pairs is going to represent a possible outcome. And step 3 is, how would I explain one trial? And we're going to get more into that. So key point number 1 for today is, if the outcome of one trial does not impact the outcome of another, then the 2 trials or events are called independent. So we are going to be looking at this key point over and over every single day. This key point tells us that things are independent from each other if the outcome of one does not impact the outcome of another. So if we think about our tennis player, so if we look at the example again, it says, how many matches on average can he expect to play until he breaks a racket and needs to use a backup? So if we're going through these simulation steps, the first one we have is to state. So it says, if a tennis player breaks a racket 15% of the time, how many matches can he expect to play until he breaks a racket? So like we said, state is just restating the problem. There's nothing new or special in this section of state. I'm just restating the problem. Where we get into thinking a little bit more and trying to develop a simulation on our own is when we move in to the plan step. Well, it tells us to design and carry out a simulation, so the design piece is part of my plan. Also, it says conduct at least 10 trials. We're just going to do 2 for time's sake. So for the plan, it says assign digits 0, 1 to 15 to be breaking a racket. Remember, our labels were 0, 0 to 99 for all possible outcomes. Well, 15 of those outcomes need to be breaking a racket because he breaks a racket 15% of the time. So 0, 1 to 15 came from this 15% breaking a racket. So 0, 1 to 15 represents that he breaks a racket, meaning all the other labels, or 16 to 99 and 0, 0, are not breaking a racket. So 16 to 99 and 0, 0, he doesn't break a racket. So I start at line 101, count 2 digits at a time. I'm counting 2 digits because these labels told me that I'm counting 2 digits at a time to get my 100% probability accounted for. Record the number of pairs it took to get a broken racket. So I'm going to be going through my table 2 digits at a time until I get a label that's between 0, 1, and 15. So it says start at line 101. Oops. So I have a little screenshot of my random digit table down here. We're only going to conduct 2 trials because 10 would be a lot for video time's sake. So if I start at line 101, I'm going to count 2 digits at a time. So my first pair would be 19. Well, 19 is in my doesn't break a racket label range. So I have to keep going because I'm going to go until I get something between 0, 1, and 15. So 19, he doesn't break a racket. 22, he doesn't break a racket. Bridge the gap, 39, he does not break a racket. 50, he does not break a racket. 34, he does not break a racket. But my next label is 5, and he does break a racket because 5, or 0, 5, is in the range of breaking a racket. So that took me 1, 2, 3, 4, 5, 6 pairs to get to a number where he broke a racket, or in that range. So that's 1 trial. Now I would repeat 10 more times. Like I said, we're only going to do 2 more. So my next one, I start at 75. So we start right where we left off. 75, he does not break a racket. 62, he does not break a racket. 87, he does not, but 13, he does. And that time took me 1, 2, 3, 4 trials. So once I conduct all my trials, and like we said, the problem will tell you, or you'll get to come up with your own number, I have to conclude. So my conclusion statement is always going to be in a form like this. This is kind of general formatting for it. So it says after 10 trials, or after the number of trials that we conducted, this case we actually did 2 trials. After blank trials, or the number of trials we conducted, we can conclude that it would take him about blank trials until he broke a racket. So this blank right here is where I have to put a percent, or a number, or the average. Meaning I need to put the average number of games he played until he broke a racket. Well, I only did 2 trials, and my trials were 6 and 4. Well, the average of 6 and 4 would be 5. If I had done 10 trials, I would have had to average together 10 numbers instead of just 2. So the average right here of 5 came from averaging together 6 and 4, which are my 2 trial numbers. So after 2 trials, we can conclude that it would take him about 5 trials until he broke a racket. And that would be a perfect conclusion statement because it has context, it references my simulation, and it answers my final question, which is what I was looking for up here. So key point number 2, for simulations, we begin with the knowns, writing out our percentages that were given, and then answer with the state, plan, do, conclude steps. So key point 3, if we are given a set sample size, then we conduct that many trials and record the proportion of observations that were in the category of interest. So that's our 3rd key point for today, and that's a wrap. We use simulations to model probabilities. For each simulation, we always conduct these 4 steps. So once again, this is section 5.1 in your textbook. Please go there to reference these problems and to see more examples. We'll do more examples in class, but your textbook is a fabulous resource. So that's a wrap. We'll see you next time.